Cisco Certified Network Associate Day 28. Welcome back everybody, I'm Imran Rafai, your trainer for this entire series. Today we're going to learn about ACL Extended, and this is going to be in continuation with what we learned in day 27, right? So we will continue from where we left. So without wasting much time, let's get straight into today's class. And like always, before we go ahead, please find on your screens our social media contact where you can contact us to get replies to your queries. And of course, please support us on Facebook and whatever medium that you can. So what are we going to look at today? Today we're going to look at three things. We're going to look slightly in depth into wildcard masks, like I promised in the last video. Then we look at extended ACL and the format by which you can configure ACLs. And then we will configure extended ACL and do a little bit of troubleshooting, right? So in the last video we learned a new concept called as wildcard mask, and I had not prepared the presentation in the video, so I couldn't explain. So I thought, I will take that opportunity in this video to explain slightly in depth into wildcard mask. So all this while, if you remember from our third video, I think day 3, we learned about subnet mask, and subnet mask helped us break the network. So if you get an IP address 192.168.100.225 with a subnet mask of 255.255.255.0, now this subnet mask helped us know the boundary where the hosts and networks are divided, right? And it helped us do a lot of things. Now in the last video we introduced you to wildcard mask, and if you go to bit level, wildcard subnet mask is going to be a series of ones, right, and then a series of zeros. Wherever it is a 0, it denotes the host part, and wherever it is 1, it denotes the network part. Now wildcard mask, on the other hand, is very similar to subnet mask. In fact, it is the inverse of subnet mask. Wherever you have ones, a wildcard mask, it is a zeros, right? So you have 0, and wherever it's a 0, it's a 1 in wildcard mask. Now this is not the rule. That means it's not always the case. Always you don't have to have this way, but for your CCNA level, right, for the CCNA level, this is always the case, right? So the best way to find, so if you have a subnet mask of 255.255.255.0 like /24, the best way to find out your wildcard mask is to minus your subnet mask from the global mask, which is 255.255.255.255. So it's 255 minus 255, it's a 0. 255 minus 255, it's a 0. 255 minus 255, it's a 0. 255 minus 0, it's a 255, and that is your wildcard mask. So if at all you have a subnet mask, immediately minus it, subtract the subnet mask from the wildcard mask, from the global mask, and then you get the wildcard mask. Now this is true a lot of times, but it's not the case, like you will see in a couple of slides later. So let's look at another one. In the last slide we saw /24. Now we look at /26, right? So if it is /26, you know 255.255.255.192, that is the last octet in your subnet mask. But if you look at a bit level, you see that you have 24 plus 2, 26 bits of ones, and then you have 6 bits of zeros, right? So if you do inverse of that, then you get 26 bits of zeros in wildcard mask, and then you get 8 bits of ones in your wildcard mask. Now, like I explained in the last video, wildcard mask, literally what it means is that wherever you have zeros, right, it says you have to match that. Wherever you have ones, it says you can ignore. That means to say, if you look at this number, right, if I gave this number 192.168.100.225, right, that means say, and if you're telling this, let's say you're configuring this in ACL saying 192.168.100.225 with a wildcard mask of 0.0.0. What is this number? This number is 63, right? So if you give a wildcard mask of 0.0.0.63, what it means is it is going to match 26 bits, right? If you say 26 bits, that means till here it's going to match, and this part of the IP address, this part, it can be anything. It could be zeros or ones. That means to say if you make everything 0 here, the number is 192, right? Everything 0 is 192, and if everything is 1, the number is 255. That means if you apply this in ACL, that means all the numbers from 192 in the 4th octet to 255, that means it's that subnet, right? Subnet of 192.168.100.192/26, that whole subnet is matched using this wildcard mask. Now at this point you should ask me this question, saying, Imran, why do you think you have two different masks? I mean, if subnet mask and wildcard mask is opposite to each other, subnet mask was enough. We were all happy with subnet mask. Why do we need wildcard mask? That's a very, very valid question, and I had this question when I was a student, and even today a lot of people have that questions. Even people who have been in Cisco world, who are working with Cisco world, not everybody has that concept cleared. So let me take this opportunity to see if I can slightly give a better idea so that you would be happy. Generally, subnet mask and wildcard mask is going to be same. So like in this case, it is inverse to each other because we are talking about network, right? This whole network or subnetwork. So when we talk about subnet, right, when you're talking identifying the whole subnet, then these both are going to be inverse to each other, right? You're going to have subnet mask and wildcard mask inverse, but then we are identifying the whole network. But in ACL, or I mean not at your CCNA level, but when you start getting more into Cisco world, you will see you will have to identify hosts, right? You will have to identify, you don't have to identify the whole network, right? In this case, like I said, the whole subnet is identified. But if you want to only identify few hosts in that subnet, then you can start playing with your wildcard mask. Because in wildcard mask, unlike subnet mask, like I said, subnet mask, you have a rule that subnet mask will always start with series of ones, then it will have a series of zeros. You can never have a subnet mask where you have few ones and then you have few zeros, and then you have few ones and then few zeros. No, that is not subnet mask. You can never have a subnet mask which will have ones, zeros and ones and zeros mixed up. Subnet mask will always be series of ones and series of zeros. Whereas wildcard, the name should tell you, it's wild. You can do anything. You can have few ones, then you can have few zeros, then you can have few ones. Whatever you want, you can have with your wildcard mask, because what you want is, you want, if whatever part of the network or whatever part of the IP address that you want to match, you make as zeros, and whichever part you want to ignore, I mean, you say I don't care what it is, right? Those you make as ones. You will have a better idea when you see the example. So let's look at another example, right? So it says identify the hosts that has even numbers in the 4th octet, right? That means you're putting this in an ACL, right? And you're gonna say write ACL command, and you say permit 192.168.100.0, and then you have to put some wildcard mask such that it permits only IP addresses with even number in the 4th octet. How do you do that? Can you do that using subnet mask? I don't think so. I don't think subnet mask, there is a value in the 4th octet that you can put such that you can only identify even numbers in the 4th octet. But look at the magic in wildcard. In wildcard, you can put this, right? Before I explain this, I will tell you what it is. If, let's say, we are only talking about the 4th octet now, right? If 4th octet number has to be an even number, the last bit, it has to be a 0. If it's a 1, it will always be an odd number. So what we can tell is, and since this is /24, that means we are trying to look at /24. In /24, only the 4th octet has even number, right? That's what we are trying to match. So we say I just have to match the first 3 octet, right? 192.168.100, and then the 7 bits of the 4th octet I don't care. But the last bit I again care, and it has to be what it is, right? It has to match with this 0. That means it has to be a 0. If at all it's a 1, I will not, it will be a deny, right? You have a deny any at the bottom, so it will go to deny any. But only if it's matching, right? If it is a 0, that means this number is always an even number. Now, I don't want to get into binary. You can look at binary values. You can start putting binary for 2s and 4s, 8, 6, all the even numbers. The last bit will always be 0. And you can also try binary for all the odd numbers, 255 or 225, whatever. All the odd numbers, the last bit will always be 1. Right? So if you put this wildcard mask of 0, 0, 0 and then 1, 1, 1, 1, 7 bits and last bit as 0, it will always match this condition, which is even number in the 4th octet. So if you convert this to decimal, dotted decimal format, the number is 254. So if you put wildcard mask of 0.0.0, it will always match and it will permit or deny whatever you want, and all the others will automatically get denied. Right? And this is the beauty of wildcard mask, where you can customize it to whatever condition that you want in your tasks. Now remember, this whatever you're seeing on the screen is nowhere close to what you have in CCNA, so don't even worry about this. This is just for your information and for your knowledge. You don't have to worry. The wildcard mask in CCNA is very, very easy. You just have to do 255, 255, 255 minus whatever that subnet mask, and you'll get your wildcard mask, because most of the thing that they're going to talk to you in CCNA is going to be subnet level, not host level, right? Another shortcut, I'm just going to go back to the previous slide. Yeah, another shortcut is if of course you can do this minus, which is very easy, but if let's say you want another shortcut, the shortcut is /26. If you remember from our table, the magic table, you see that /26, the block size is 64, right? If the block size is 64, the wildcard mask will have the last octet value as 63, right? 1 minus 64. If it is /25, the block size is 128, right? If it is /25, and then this number is going to be 127, right? So this is another shortcut. But if you don't want to do this, do the normal method where you minus your subnet mask from the global mask. Right. Next, we're going to look at extended ACL syntax, right? So like we looked at standard ACL, there are two ways of configuring ACL. One is the classic syntax, and then you have the modern syntax. In classic syntax, of course, you put access list, the keyword, then you put numbers 100 to 199, the numbers that is there for the classic ACL. Then you put deny or permit actions, and then you give a protocol. Now this is where it changes in compared to standard. In standard, you just had to give a source IP address. There is nothing else that you could do. But in extended, you can start filtering depending on the protocol, depending on destination, and many other things, right? So protocol, you have IP, right? IP is the entire IP protocol suite. That means every traffic, right? Because we are working in the IP world, right? So every traffic in IP will get it'll get filtered depending on permit or deny, whatever that action is, it's going to take. But then this is every traffic between this source and this destination. Under IP, there are 3 protocols. That is, you can do ICMP, right? That's ping. Then you can do TCP, and then TCP you can do different ports, 21, 23, 22, whatever, right? You know, maybe what I will do is I'll post a link. I think there is a Wikipedia link that we discussed when we discussed day 3, right? I'm going to put that same thing, which will give you a list of all the TCP and UDP ports, right? And then the other one, like I said, is UDP. So you have TCP, UDP, and then of course the port numbers depending on the application that we are trying to block. Then you give the source IP address, and then you give the wildcard mask, right? Wildcard mask we discussed, and then protocol info. Now protocol info is where you give the port numbers, right? So here in protocol you'll just say UDP, ICMP, IP, whatever protocol, and in protocol info you'll say what is the source port number. Then you'll say destination IP, destination wildcard mask, and then destination port numbers, right? So generally, if you remember from our discussions that we had with data flow, source port numbers are going to be a random number, right? The sending device creates a random source port number. If you're blocking traffic flow and if you're saying block for FTP traffic, it's always the destination port that we're bothered about. It's not the source port. Source port is always going to be a random number. So most of the time when you're configuring access list, you would be ignoring the source port number. You will not be putting any information there, right? But you will be putting protocol information for destination, because that's what you want to block, right? So we're good till now. Similarly, the modern syntax, now if like we discussed in classic, now if you want to do another access list and you can have another permit statement, you have to type this whole thing once again, right? And then we have the same limitation that we had in the standard ACL. The modern way of doing it is by putting the IP keyword, and this IP has nothing to do with this IP. This IP and this IP, this IP is a keyword, this IP is protocol, right? So you put this IP, that's a keyword, and then say access list, IP access list, and then you have to choose extended, of course, because we're doing extended ACL. Then you give an ACL number or name. You can give anything you want. You will go to a sub-configuration mode, that's extended NACL. Then you can put deny or permit statement and then protocol, exactly like we discussed here. Then source IP, wildcard mask, again protocol information, which is, again, like I said, we will be ignoring that. We will not be putting source protocol port protocol info most of the time. But of course, there might be scenarios where you would say the traffic going from this port number to that port number, right? So, but most of the time in your CCNA level, you will be ignoring that. Then you will have destination IP, wildcard mask, and protocol information, which is nothing but your port numbers. And applying ACL is the same whether you're using standard ACL or extended ACL. It's the same syntax, which is interface. You get into the interface, then you say IP access group. Remember, applying is using access group, creating is using the keyword access list, right? Then you put the number or the name that you configured earlier, and tell the direction of flow of traffic, whether it's in or whether you're going out, right? And you know how to identify the flow of traffic. I don't want to discuss the same thing that we discussed on the last video. Right, so let's look at a scenario, and we'll try to configure this. So our first task, it says management and account can access HTTP 80. HTTP 80 is nothing but web traffic, right? And FTP traffic only on server 0, right? That means to say this whole network of management can access server 0, and this whole accounts network can access server 0, right? And not all traffic, only traffics are port 80 traffic and port 21 traffic, right? That means port 80 and port 21 are the only traffic that should go through. All the other traffic, so if they want to do SSH, for instance, that should get blocked. Only FTP and HTTP should be allowed to pass through, right? Now, if you remember from our discussion, extended ACL, where do you apply extended ACL? Extended ACL should be close to the source, right? So for management ACLs, we will put it close to the source, which is nothing but this, and for accounts, closer to the source, which is nothing but this, right? This is where we will be applying, and we want to block when the traffic is going out, so it will be in traffic. And when you say in and out, it is with respect to the router that is in traffic, to the router that is in traffic, right? So you're blocking in the in direction. So what are the commands? So we'll say ACL. We'll do the classic approach for the management ACL. We say permit TCP. Why are we saying TCP? Because HTTP port 80 is TCP. If you had given permit IP, that means it will let everything go through, but we only want TCP port 80. So we're saying permit TCP 192.168.1.224/28. Of course, we use the wildcard mask, but this is just a pseudocode for us to discuss. Of course, when we put this in packet tracer, we will be converting this to wildcard mask. So we say 192.168.1.224/28, which is the entire management network, going to 192.168.1.194. 194 is nothing but this server 0, right? 194/32. That means we're talking only about this server 0. Right, /32 is nothing but host, and we're telling port number, destination port number 80, we're permitting. That means we're permitting HTTP traffic. Then the same command, we're telling permit port 21, which is FTP traffic. And then what happens, because we don't give anything else, at the bottom there is an implicit deny any, which means any other traffic. That means, say if this laptop, right, wants to communicate with laptop 2 from sales, it will get denied, because I mean, we know this. It'll check the first line, it doesn't match. Second line doesn't match. It'll definitely go to the third line, which is deny any. Correct? Right? So every other traffic would be blocked. That is, where do we apply this? We apply this in R1 to in direction to R1's G0/0, which is here. Next, to do the same thing for accounts, because we need to do it for management and accounts, we do the same thing, port 80 and port 21, going from the whole network of 128, which is what nothing but the accounts network, applying the in interface of R2's G0/0. That completes our task 1. Next, it says sales can access all protocol except ping only on server 1 from server room. That means to say this whole network of sales, it can only access server 1, right? It can only access server 1, but it can do everything. It can do HTTP, SSH, whatever you want it can do, except for ping, right? It can't do ping. So we need to do that command. So what do we say? We say first thing we need to, because we need to allow everything else, only ICMP we need to block. That means to say we need to first block, right? Like we discussed, the specific ones need to come on the top, and then the general one. So IP is a general thing, everything. So we want to permit that. So we are going to put that ICMP deny. So we're saying deny ICMP traffic coming from 192.168 to 1.0, right? The 1.0/25, which is the entire sales network, going to 192.168.195/32, that is server 1, just the server. Echo. So when you say ICMP, there are many messages. There is echo, which is the first message going from here to there. Then there's an echo reply, which comes from there to here, right? So we are saying any traffic going from here to there, that is nothing but echo. You please deny that. And then it says permit all IP traffic, right? Everything going from this network to this server, allow. Below that, there is an implicit deny, right? So if this computer tries to communicate here, it will not go through, because there is the third statement which says implicitly, it says deny all other traffic. So that completes our task 2. Next, let me just clear the screen. Next, we look at task 3, which is laptop 2 of sales, which is this, and let's assume he's a manager for sales. And then it says PC 0 of accounts, and let's assume he's a manager for accounts. They both need to access laptop 0 of management. Let's assume he's a CEO, right? So they should be able to access laptop 0, and it doesn't say anything else. That means to say they need the entire IP protocols access to laptop 0, including ICMP, right? So every traffic should go to the CEO's computer from these two computers. So what do we need to do? If you remember, there is ACL here, that is this one, right? And there's an ACL here, and there's an ACL here, right? Like, because in task 2 we applied it in the indirection of G0/1, which is here. So now there are ACLs everywhere. At the moment, laptop 2 cannot communicate with this, because if laptop 2 tries to communicate with laptop 0, first it looks at this, it doesn't match. It looks at this, it doesn't match. It matches the third deny statement, and of course this will get denied. Now we need to do something. We need to add more ACL statements in ACL allow SA for this computer to go through, and similarly we need to allow ACLs in this also. We need to add more ACL commands to let that traffic through. So what do? We need to allow. So let me look at that. Okay, so right, so we need to add this permit command. So we say permit IP 192.168.1.2, which is the laptop 2, that's a host, going to 226, which is the laptop 0. It's saying permit IP. That means permit every traffic going from here to there. Similarly, in this ACL, we are going to say permit IP, same way. This computer going to this laptop, let through that traffic, right? This gives us all the thing. Now, if you remember, I told ICMP works two-way. That means you send one traffic, right? You send the echo message, and then echo reply has to come back for it to say, okay, ping successful. So now in this situation, if laptop 2 from sales send a ping to the laptop 0, because of this ACL, it says IP, it let everything go through, so this traffic will go, ICMP echo message will go to the laptop 0. Laptop 0, when it gets the ICMP message or the ping message, it will reply back. When it replies back, the ACL 101 will get hit, and ACL 101 will look at the traffic. It says, okay, it's a echo reply coming from laptop 0, that is 192.168.226, right? It's 226, going to laptop which is 192.168.1.2, and it looks at the ACL statement. It says, okay, this is not matching, this is not matching, the only thing that is matching is deny. It will block it, right? So we need to put a permit statement in ACL 101 to let echo reply out, right? So we say permit ICMP 192.168.1.226, which is laptop 0, going to 1.2 reply, right? It's echo reply, let it pass, right? Similarly, we let traffic going to 130, which is PC 0, right? If it's an echo reply, please let it go through. Then this PC will be able to, this laptop 0 will be able to send the echo reply back, and that ping message, or when you do ping, it will successfully work. So that will complete our task 3. Next we look at task 4, and let me clear the screen once again. This says laptop 3 of sales, that is this guy, should only be able to access its own network. That's the sales network. That means you say this PC, whenever it tries to communicate out, automatically the traffic should get blocked. But it can only access web services on server 1. So if at all it's all of the traffic, it will get blocked. But if it's a web traffic going to server 1, right, it's HTTP traffic, that will let through, right? So what do we do? What is the ACL that we are bothered about? This is the ACL that is here in R2's inside interface, right? What is, I mean, inside direction in R2's G0/1. That's the ACL that we are bothered about, which is nothing but this ACL. In that ACL, we need to change it to first permit TCP. So it says specific. It says permit TCP, right? Port 80. That means if at all it's a HTTP traffic going from this computer or laptop 3 going to the server, permit that. If at all any other traffic, it's doing FTP, going from 192.168.1.3, which is this laptop, going to anybody, right? Any keyword, it says deny, right? So any other traffic coming in, it will get denied, and then we continue the old task ACLs, and that would give us a solution to task 4, right? So like I said, whenever you're designing ACLs, always take a pen and paper, or maybe on your laptop, type on a notepad, because we have to change. I mean, if at all we had started typing ACLs, and after putting these 3 commands, if I had tried putting these, it will go down, right? It will come here. It would have been no use, because if you see permit, this whole network I have already permitted. That means if this command, if this deny was down here, it wouldn't have worked, because whenever laptop 3 tries to communicate out, these commands, right, would have let it go through anyway, right? So the order matters. The order really matters, and that is why you need to first design it on a piece of paper and then finally start typing it onto your router, right? So let's go to packet tracer and try to configure all these things there, right? So this is the task that we discussed, and the solution is given on the right, what we already discussed. And let's try to go through all the tasks and see if we can establish that and work it, right? So let's go into router 1, and it says show access list. There's no access list at the moment. So what I've done is I've configured these routers and these devices accordingly, and I have I'm running RIP routing, so I can say show IP route, and you can see that RIP is running, right? RIP is running, and RIP has already learned few networks, so that's fine. So there's communication. So at the moment, let's go to this computer, right? And this, at the moment, if I ping server 2, right, server 1, that is 192, ping 192.168.1.195, at the moment it should work without any problem, because we have no ACL that's preventing or filtering those traffic. So you can see that it is working. and if I do 194, which is server 0, which is the only server that it should be able to access, it should not be able to access anything else according to our task 1, which is also working, right? So we'll go ahead and put that ACL. So we'll go to this device, router 1, and configure terminal. I say access list, and then I can put 101, which is access list number, and then I say permit, then I say TCP, right? Look at this. Now you have all these things. We can do IP, OSPF, TCP, UDP, GRE, ESP, EIGRP. So you will not be doing all of these in your CCNA level. Mostly you would be doing IP. I mean these four I would say: UDP, TCP, IP, and OSPF. IP and ICMP, OSPF, ESP, GRE. No, normally these are into, like I said, VPN. If you're getting into VPN, which is not part of your CCNA, you don't have to really worry about that now, right? So you only worry about, like I said, UDP, TCP, IP, and ICMP. So in this case, it's going to be TCP, right? And then what do? We need the whole network, right? So it will be 192.168.1.224, right? 224/28. If it is /28, what is the block size? If it is 25, the block size is 128. If it is 26, it is block size is 64. If it is 27, it's 32. It's 28, it is 16, right? 128, 64, 32, and 16, right? So if the block size is 16, the wildcard mask, this is a shortcut, will be 15, right? /28. 28 means 4 bits are borrowed. If 1 bit is borrowed, block size is 28. If 2 bits borrowed, block size is 64. If 3 bit borrowed, block size is 32. 4 bit borrowed, the block size is 16. That means your wildcard mask is going to be 0.0.0.15. That's one way of doing it, but if you don't want to do it, just look at what is a subnet mask for /28, minus that from 255, and then you will get the wildcard mask, right? And then where does it go? So we're talking about the whole network of management going to server 0. So server 0 is just one server, so we can do host. We say host, and we say 192.168 1.194, and then we can say you have these operators. So you can say equal to, that means it will match that port number. You can say greater than if you want to say all the port numbers more than port 20. You can say less than if it is less than port number 20 or whatever, right? There are different operators. Not equal to, you want to allow everything else except for one protocol, then you can say not equal to, right? So you can look at different things. You can give a range, right? But for your CCNA level, I think EQ, which is not equal to, right? We're just matching that one port number, and we say port. After that, you can say your port number. So you can say port 80, or you could just give www FTP POP3 SMTP whatever, and automatically take 80. So I will say 80, and if you look at the running configuration, you will see that it has taken www, which is nothing but port 80, right? Now next, same command, I'm going to say port 21. Now if you can see from our thing, it says port 21. We're going to let port 21 in the same direction. So now that is done. I think our first task is done, but we're going to type everything so that we don't forget. Then we say permit, the same thing, same access list 101 permit. And now I want to permit ICMP. Earlier we did TCP, now we're saying permit ICMP. ICMP where? Going from 226. 226 is laptop 0. So I can say 2 is, I can say host, like we did in the last thing. Here I said host, right? If I want to give /32, I can say host, or I can just do the normal way. I can put a wildcard mask of 0.0.0.0, whichever. This is a more tedious way, but I'm just going to show so that we know the different ways of doing it. 192.168 1.226 0.0.0.0, which is nothing but host, that host of 226, going to 192.168. Again, here also you could do that, but I'm just going to do this because it's much more easier. 192.161.2. And what do you want to let? Like I said, ICMP has different messages. Echo reply, host unreachable, net unreachable, port unreachable, protocol unreachable, TTL exceeded, unreachable, whatever that you want. We can message type, right? Type of message we can start blocking. In this case, I want to do an echo reply, so I'm saying echo reply, right? Only echo replies I want to permit. And then same thing, I'm gonna let, but this time the host is not 1.2, it's going to be 1.130, right? So I'm going to say 1.1.130 and echo reply, right? So I've let through both the echo replies. Now I'm going to apply this interface G0/0 IP access group, and then I give the access list name, which is 101. Inbound or outbound? Inbound. Perfect. Right. So now we have done that. Now let's see if we can ping that. So we try the same thing. Ping 192.168.1.194. Earlier this worked. Now it says destination host unreachable. Why is that? Even when I do 195, it says destination host unreachable. If you remember from our task 1, it said from laptop 0 I should be able to access server 0, but we allowed only HTTP and FTP traffic. We did not let ICMP traffic. That is exactly why this is getting blocked. If you do web traffic, I go here and I say 192.168.1.194. yes, web traffic is working. It can access the web servers and it is working. If I try 192.168.1.195, which is server 1, will it work? It says it's trying, and it'll come back and say request timed out, which is exactly what we're expecting, because this access list is blocking that request. So our task 1 is not exactly done. We have to do the same thing for accounts. So I'm going to go here, enter, show access list. There's no access list. Configure terminal, and I'm going to do the modern way here. So IP access list, and then I'm going to give an extended keyword, and then I'm going to give a name which is allow AC, right? I go into a subcommand, and then I say permit TCP 192.168.1.128, right? 128, and it is /26. That means 2 bits are borrowed. If 1 bit is borrowed, the block size is 128. 2 bit borrow, the block size is 64. So wildcard mask is 0.0.0.63. right? If you don't want to do this method, you can very well go and do the other method where you look at the subnet mask, the last octet of the subnet mask, and subtract the subnet mask from 255.255.255.255, and then you will get your wildcard mask. So whichever way you're comfortable with, please use that. Then I say host 192.168.1.194, and I need to say equal to port 80. The same one equal to port 21. I'm letting through these two things. Then I want to let through, this is for another task we did, 192.168.1.30 going to 226, right? This is the last task, task 4, where this traffic going from this computer to laptop 0, I want everything including ICMP to let go through. So I'm going to type that as well, permit IP host 192.168.1.130 going to host 192.168.1.226, and I can say enter because I just want the entire, right? This is definitely, I mean, the DSCP and precedence you really don't want to worry about in your CCNA, right? You just hit enter here and that will apply. Now let's apply that into our interface. So interface G0/0, right? I say IP access group, and I give the word allow AC, and I want it to the in direction. So when it's in direction, please block. So now, like I said, this PC should not be able to ping, but this PC should be able to do a web service 192.168.1.194, right? It is definitely working, no problem at all. This PC can go to the server for a web traffic. It is working. If it tries to ping that same thing, it will not work. So I say ping 192.168.1.194. Ping will not work because this device, this router, will block that traffic. Now let's do a new access list. IP access list extended, and then I give the word allow SA. I go into a subcommand. I say permit TCP host 192.168.1.3. right? That means that computer going to the server on a web traffic will only let that through, right? Going to host 192.168.1.195 equal to port 80, right? Only HTTP traffic I want to let through. I want to deny everything else. Deny IP going from host 192.168.1.3 and going to any. So any traffic going out from this thing, from 1.3, which is laptop 3, if you remember our task, from this task, anything that is going out I want to block. Then I'm going to tell deny ICMP, right? This is one of the tasks that we had, which said allow all IP traffic going out of this network, except for, this is for another task which said deny ICMP, that is ping. Except for ping, everything else should be allowed. So we are first denying ping. So when I say deny ICMP 192.168.1.0/25, how many bits are borrowed? 1 bit is borrowed. That means the network ID is 0.0. I mean the wildcard mask is 0.0.0.127, right? Because the block size is 128, and going to the host of 192.168.1.195, and then we need to block echo, right? It's not the reply, we want to block the echo which is going out. Then we say permit, we're permitting the entire IP protocol going from 192.168.1.0 0.0.0.127, right? Going to host 192.168.1.195, right? That means the entire network can communicate with that server 195, which should perfectly fine. And then this is for the last task, which says permit traffic going from laptop 2 to laptop 0. So permit IP host 192.168.1.2 going to host 192.168.1.226, right? I'm going to say all traffic going from here to there, please apply. Then interface G0/1 IP access group, then we say allow SA, and which direction? In direction, right? Now this PC will see if he can do anything, if he can ping anybody else. Ping 192.168.1.194.195, which is server 1, it will not work. Let's say if he can ping this PC, that is 1.30, 1.130, he cannot ping there as well. Let's see if he can ping the laptop 0 of management 226, he can't ping there. What can he do? He can only do a web traffic to the server, that is 192.168.1.195, which is perfectly fine, it's working as expected. Now this laptop should be able to access every traffic at laptop 0. So I say even if he wants to ping, it should work. Ping 192.168.1.226. It is working. He's getting a reply back. He can't do to anybody else. 227, which is laptop 1, it will not work. Only to laptop 1 we have let through. And also he should not be able to ping 195, which is server 195. He should not be able to ping, but he should be able to do a web service there. 192.168.1.195, and it is working. So we have established, right? We have finished all the tasks. That is all the 4 tasks we have established. Now, is this the most efficient way of doing the task? I don't know. This is my way of doing the task. So that's the beauty of ACL, and that's the beauty of anything in networking. There is no one right answer. There can be multiple answers. It all depends on what you want it to be. It all depends on your design. If you want to design your network in a different way, of course you can design the network the way you want. So the beauty of CCNA is where you are learning all the concepts. So the best way to learn that is by designing your own network. The best way what we will do is try to find a different answer, or try to answer these tasks in your own way, right? I'm sure there are much efficient way of doing this. So take this opportunity, write those ACL commands yourself, and comment in the comment section here on YouTube, so others will have inspiration from your way. So if you might have done it in a different way, and others can look at the comments and they can also have a spark of thought, and they say, okay, you can do it this way as well, right? So feel free to comment. Even the previous video, day 27, after the video finished, I saw that there were few task objectives that we did not meet. It was an oversight. So that's also a task for you. You go to that video, watch it again, and see, okay, what is the task objective that we did not achieve, and try to answer those and comment in the comment section in that video, right? So that's going to be your task for this video and the previous video. So that concludes day 28. Thank you for watching. If you have any queries, please feel free to write into us, comment on our videos. We will, if I can't answer, if one of my team can't answer, there are a lot of community members who I've seen are wonderfully helping each other. So that's the community that we're trying to establish here at NetworKing. So if you know the answer, please feel free to help your colleagues here who are your fellow learners, right? That's the way you learn. And the best way I've realized that the best way to learn anything in life is to teach somebody else. So if you think you know something, please try and teach them, because it is going to come back to you and you are going to get your concepts cleared. So that is the lesson for this video. Thank you so much. We will come back in a new video very, very soon. So we will be finishing ICND 1 very, very soon. Stay tuned and good luck.